Today we're going to be looking at the CREO Simulation extension. Now, CREO Simulate delivers analysis capabilities that supports designers, especially during the early stage development process, because it helps reduce the product development costs. Designers can utilize the analysis results to define safe working conditions, like the maximum loads, or even reduce material costs by removing expensive geometry choices and comparing the results to a new design. Now, CREO Simulate, or the extension, can do linear static structural analysis with small displacement, modal structural analysis, linear buckling structural analysis, and even linear steady-state thermal analysis. For this demonstration, we're going to be focusing on the linear structural analysis part mostly. And for those that don't see the need for thermal or modal analysis, CREO Simulation Elite is still packed with all the features that you would typically need, like your force and moment load types, and even your displacement constraints. So now for the technical demonstration. So what we've got here is an assembly with some square tubing, staircase, and an I-beam. Just to show some of the preparation that I did beforehand, what we've got is some welds. And if I just go into my sections, what you can see here is that it is designated as a solid weld. So I didn't use the surface feature within the welding. Just going to zoom out. And I'm going to take away the cross section. So if I click here on my feature tree, you'll see that we've got our welding for the stairs and the welding of the I-beam. Then as a separate feature, I've got the welding for our anchor plates on the legs. So now over to the CREO Simulate part, we can see a few annotations that are popping up. So here, firstly, what we've got is a material assignment for the top frame. Also got some weld connections here, but only for the top 4. And then we've also got our constraints at the bottom. So typically what I like to do is I first go into my refine model part. And here we can see some of the idealizations if you want to simplify your design. As we know that some of these solvers, they can take extremely long the more facets you've got. And we've also got our interfaces. We can have the welds. What I'm going to do first is I'm actually going to detect the weld so that I can get my second feature. And just to bring your attention back to the feature tree, as you can see just below our rollback bar, we have our simulation features. So if I open up my connections, you can see there that within CREO Simulate, we've got our first weld connect. So now I'm going to detect the weld, and now it's asking for the components. Just to make it easier, I'm just going to select the entire assembly. So we're not too worried about the thickness here. The welding thickness that I used was about 6 millimeters. Just going to say start. And in our message dialog box, we can see that weld objects created for 1 weld features. So now we can see that weld connect 2 has been picked up, and then we can see the additional icon. The other thing that we can also do is divide surfaces. So for this one, what I did was I created, as you can see, you've got the sketch feature within your simulate. And what I'm doing is I want to simulate a tank that is roughly the size of the green sketch there that's highlighted. But now what I want to do is I actually want to divide the surfaces so that it only acts on those parts. So I'm just going to hide my sketch quickly. So you can see that I've already done the opposite side, where as I select it, only the middle part selects. But as I click here, it selects both sides, seeing that that is a single surface. So we're not dividing the entire component, we're just dividing the surface that a force is going to be acting on. So for that, I'm going to jump back into my home feature here, or home tab. I'm going to add a force or moment, and we're going to select our features. But now, as I come to this last point here, I can see that I haven't split this one up yet. So, go back into our redefine, I'm going to say divide features. Now, CREO is asking which component you would like to divide. I'm going to click there. And now it's saying from the component that you selected which surfaces I want to focus on. So we're going to select that face there. And now we're going to click sketch. And then we can see how the surface is divided. So now going back, we're going to go and place our load again. So now when I select it, now we can see that it's only acting on the divided surfaces that I have now allocated. So just for these purposes, I'm just going to say -2, and it is in the Y direction. Here we've got a little triad indicating which direction is positive for our axes. And we're going to select the ton unit. So we can hit preview, and that gives us a arrow just to indicate that our direction is correct. So if I were to change this to 2 and I hit preview, we can see that it's pulling upwards. So there we've got our 2-ton tank, or just of course for demonstration purposes, I'm putting in 2 tons. And now if we focus once again on our loads and constraints, what we've got is we've got the surface of the stairs just constrained, the bottom sides of these 2 plates for the anchor plates. I'm just going to rotate the model, and here we can see we've even got those holes anchored as well. Now just to show you how simple it is, we came in, and as I hold Control to multiple select, we can see that it automatically selects both halves of the circle. And as I click OK, before I do that, we can see that with the translation in all the directions, we can set it to free, fixed, or prescribed. And under rotation, you can also define it as free, fixed, or prescribed. And then we can see our annotation for the constraints. So what we can do as well, and just refine model before I get into there. So during the model setup, what you would typically do is you would go in here and say the default interface. Now you see what that means shortly. So you can say the default. This is when CREO tries to analyze all your surfaces that are touching the interfaces, and you want it to be by default bonded, free, or contact. So because we're dealing here with mostly a welded structure, instead of going and welding each and every piece and adding those features, what you can also do is just have it as a bonded. It won't be as accurate, but it is going to give you an indication that when those structures can't be separated, how will the structure act? I'm just going to cancel that now, so we don't want to change anything. And to show you what we mean by the interfaces, I'm going to go on Refine Model, Review Geometry, and then hit Apply. So now we can see the changes here. And what we've got is, here we've got 2 bonded interfaces. So this is the stairwell, and we can see that where these 2 faces are touching, it turns purple, which means bonded interfaces. And if we go over to our weld part, we can see that the inside is bonded, and the outside, which is then turquoise or blue, will be our weld feature. And if I zoom into here, so here I didn't add any weld features, but this is how CREO then automatically picks up, like these 2 parts are not to be separated. So now as for our auto geometry, I have already done this previously. So I'm just going to let it load the mesh. Now I will add there are some controls. So as you can see here, this is quite a bit of a rough mesh. It's just for simplicity's sake, but here you can see the controls where you can assign maximum element size for each part individually. You can have the edge length by curvature, minimum edge length. You can do a lot of refinement if you so wish. But just for the demonstration purposes, I did this previously. And it took about, I think we can do diagnostics. Doesn't seem to be popping up right now. But this took around, let's go here, model summary. Here we can see that our element size is 72,000, or number of solid elements, I apologize. And then here we can do AutoGem, here we go. So we can see the elapsed time was about 2 minutes. Just gonna wait for that to close. And now we can go over to our results and open our analysis. I have, as you can see, that it has been completed. But what I wanted to show is that you can go into your run and then settings. Here you can allocate how much RAM to be used for your simulation. So by default, this is set to 512 megabytes. And my configuration has been set up to be around 8 gigs. And you can set the default if you want to in your config. I'm going to cancel that. And I'm going to use the default template to show our results. Just going to wait for this one to load. And like I said, I am using currently the default template, and here we can see. Now the one on the left, I know that looks particularly rough, but as you can see here that it says that it's being deformed. So when you double click on it, what you can do is you can go over to quantity. Let's say we want to change our units here. So we're going to stay on stress, but we're going to change it to gigapascals. And we're going to go over to our display options. Now here's where the animation, you can change that, and let's say we're going to change it to 20. And what we can do is, so the deformed option is what has been enabled here. Just so you can see under, it's overemphasized, and it's essentially just showing you how the structure reacts, not necessarily how far it deflects. In the bottom left there in our dialog, we can see that it's working on the different frames. And here we can see that it's still running frames, but now the deformed function has been disabled. So now we can go around and we can see, okay, so here are most of our stress raises. What you can also do is you can format with this one selected, we can edit it. So let's say, for instance, we want our values to be from 0, minimum, 1, and then here we have the checkbox for scale between min and max. And what we can do is we can just change this on our color wheel a little bit, just so it's a bit easier to spot. And let's hit OK. Now it's just going to work through the frames again. Looks like I didn't assign the max value, but that's not a problem. And then we can see the color change now. Now when we rotate it, you can see that most of it is focused around the bottom sides here, like here for instance on the weld. Now here in the middle we've got our displacement, and here we can see that the maximum is here in the middle and it's going to be deflected by around 2 millimeters. What you can also do is, if you want to create your own, you can just copy this window, and let's say we want displacement, millimeter, component magnitude, but what we are going to do is we actually want to keep the properties that we assigned for this one, like the animation, and we actually want it deformed. So you can also overlay your undeformed, that will give a little ghost image of what it is without being deformed, but we're just going to keep that. as is. So now when we click OK and show, it's going to add a fourth screen, or fourth window. And here we can see our exaggerated, because I have the deformed enabled, displacement window activated as well. Thank you very much for watching. If you do have any questions, feel free to send us an email at product1, and we will get back to you as soon as possible.